Today's lesson, Tuesday, August 25th, we will continue estimating non-perfect square roots. So on Friday, we did talk about perfect square roots. And here are some perfect square roots on a number line. Okay, and we'll just fill these in. And perfect squares, what we've learned is think of this as the area, right? And it's a square. So think of a number times itself to give you the area of 4. What number times itself? 2 times 2 is 4. So the square root of 4 is 2. 1 times 1 gives you 1. So the square root of 1 is 1. The square root of 9 is 3. 3 times 3 is 9. 4 times 4 is 16. The square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. 10 times 10 is 100. And then yesterday in class, we talked about non-perfect square roots. A square root that is not a perfect square is called a non-perfect square root. And so you saw that in yesterday's discovery investigation lesson in your Desmos. The values of non-perfect square roots fall between two consecutive perfect square roots. All non-perfect square roots are irrational numbers. We can see that the perfect square roots are integers. So our non-perfect square roots are irrational numbers. All right, so let's get to estimating our non-perfect square roots, and let's look at our first example. Example number 1, we're going to estimate the square root of 23 to the nearest 10th. Let me scroll up just a little bit more so I can refer back. Okay. All right. So we are going to estimate the square root of 23 to the nearest 10th place. Okay, so the square root of 23, the values of non-perfect square roots fall between two consecutive perfect square roots. So there is not a number times itself that's going to give you 23. There's not an integer. Okay, so square root of 23 falls between, and we can look back up here at our perfect square root number line, and we can see that the square root of 23 falls right in between the square root of 16 and 25. So two consecutive perfect square roots is 4 and 5. Consecutive means a number right after each other. Okay, and so let's fill that in. So the square root of 16, the square root of 25. So we can see that the square root of 23 falls between these two perfect square roots. Okay, so we can see it's going to be between 4 and 5. So we're estimating, right? So we know that it's going to be 4 point something, right? So we know our whole number is 4. Now we're going to determine how to get the decimal, and we're going to round to the nearest 10th place. Okay, so in order to do that, we are going to set up a fraction, right? And so since we're going to get a fraction, we will need to divide to get your decimal, right? To get to the 10th place. All right, so to get our numerator, okay, we are going to find the distance 23 is from 16. Okay, so the distance, and we can just subtract. 23 minus 16 is 7. Okay, now to get your denominator, that's your whole. So this is part of the whole. Okay, so 23, right, is 7 away from 16. Out of the whole, right, would be 25. So what is our total distance from 16 to 25. So we're just going to subtract 25 minus 16, your perfect square roots, and that's going to give us 9. Okay, so we are going to round to the nearest tenth, so we are going to divide. And a trick is 7/9. Any ninths is actually your numerator repeating. Okay, of course I will show you that we are going to divide. 7 divided by 9. This is all without a calculator. So no one should be using a calculator. It should not be out. So let's use integrity there, right? So 9 cannot go into 7. 9 can go into 70. 7 times 9 is 63. We're going to subtract, and that gives you 7. And you can see it's going to keep repeating 7. Okay, since we are going to round to the tenths place, we're going to look at the hundredths place. And this is 5 or greater, so that's going to bump up to 8 tenths. All right, so the square root of 23 is about 4.8. And that's how we estimate our non-perfect square roots. Okay. So the square root of 23 is actually probably around here on the number line, since it is 4.8. This is just an estimate. Okay, this is just an estimate. It is irrational because the decimal does keep going on without a pattern. And so if we put that in our calculator here, 7 divided by, oh, sorry, that's not what we wanted. The square root of 23, right? See how close we were? 0.7 repeating. That's pretty accurate, right? So notice that it is irrational because the decimal keeps going on forever, right? Without a pattern. There is no pattern here. And again, the calculator can only hold so many digits in the calculator. Okay? So it is an irrational number. And see, that's a pretty good estimate from what we saw in the calculator. Let's look at our second example. We're going to estimate the square root of 41 to the nearest tenths place. Okay, so the square root of 41, we're going to place in the middle. And then our note says it's between 2 consecutive, right, perfect square roots. So the square root of 41 falls in between here. It falls between 6 and 7. So let's go ahead and fill that in on our number line. Square root of 36 is 6, and we know this is going to be 7 because consecutive is right after another. So let's fill that in. That's going to help us set up our fraction. And so we know it's going to be 6, right? 6 point something. So 6 is going to be our whole number. It's not quite 7, right? The square root of 41 is below the square root of 49. Okay, to get our numerator, we're going to find the distance from here to here. And again, we can just subtract 41 minus 36, and that gives us 5. Okay? Now to get our denominator, we want the total distance. Okay? Square root of 41 is part of the whole. Okay? So this is our whole right here. Okay, so 49 is how far away from the next perfect square root, and it is 13. So there's our fraction here, 5/13. Okay, we got our fraction. Now we're just going to divide 5 divided by 13. Bring your decimal straight up. 13 cannot go into 5. 13 can go into 50 3 times. 3 times 3 is 9. 3 times 1 is 3. And we'll subtract. Gives us 11. Since we're rounding to the tenths place, we need to go out to the hundredths place. So added a 0 there. Go ahead and bring it down. 113 goes into 110. 8 times. Okay, so looking at our hundredths place, it is 5 or more, so that's going to bump up the 3 to 4. So it's going to be 4/10. So the square root of 41 is about 6.4. The squiggly equal sign just means about. So this is just an estimate. Okay, so let's pull that up actually on a calculator just to see how close we were in our estimating. Square root of 41. Oh, look how close we are. It's about 6.4, right? And that's what we got. And notice how it is irrational. The decimal keeps going on, and there is no pattern. Okay, so that square root of 41 is an irrational number. All right, that is it for your notes. On Canvas, there is some practice for you with answers, and then also an extra practice.